you're a resident of Pennsylvania or the Northeast United States, you've likely heard the term polar vortex being thrown around in recent years. After record-breaking cold in the winter of 2015, it's a term that's being more commonly used in the media. But what exactly is the polar vortex, and how does it affect our weather here at home? Dr. Melissa Jervis is a professor of meteorology at Penn State. She conducts research in atmospheric and ocean circulations, something very relevant for a phenomenon like the polar vortex.
The polar vortex is a set of winds in the upper atmosphere, so in the stratosphere, as we call it, that rotate clockwise around the Arctic pole, and it also occurs in the Antarctic. There's also an Antarctic polar vortex, and this is related to pressure at that height being lower over the central Arctic.
The polar vortex lasts year-round. The stronger wintertime polar vortex is typically more tightly packed, holding the coldest air north of the United States. But through both natural variability and climate change, the polar vortex can disassemble or weaken, weakening the flow over the Arctic, which usually means trouble for the United States.
It's nice and circular. It's like it's confining the cold air to the Arctic. But when it starts to become more elongated, or if it splits, then that cold air can travel a little bit more further south.
What immediately comes to mind? The winter of 2013-14 and 2014-15.
What made those two winters so interesting and so cold from our perspective was not that it was the coldest. You didn't have the coldest days on record, but what you had was a persistent cold winter. So in that case, we were stuck in that same pattern for most of the days of that winter, and so that's what really made it such a record-breaking, or at least seemed like, a very important, very different kind of winter.
Research has shown going forward more disassembling of the polar vortex may occur. This can be enhanced by reduced snow and ice cover in the Arctic. The melting of snow and ice leads to less reflected solar radiation, which means increased evaporation and transpiration, thereby altering the pressure and temperature gradients of the polar vortex. When jet stream amplitude increases, atmospheric Rossby waves propagate to the south, transporting warmer air to the poles and polar air into lower latitudes.
I mean, there are a host of things that are happening with global climate change. It is a complicated problem. You have changes in circulation in the tropics from increased temperatures. You have reducing Arctic sea ice cover, you have changes in the ocean temperatures, and all of these things can impact the mid-latitude circulations. And so this is very, very active area of research right now. It's difficult because it's really hard to tease out all of these different factors.
While the polar vortex typically brings unusual cold to the northern United States, it's important to remember it's a very natural feature of our climate and atmosphere. While still a hot research topic, Dr. Jervis' research shows this disassembling of the polar vortex has become more common in recent years, with projections that this will continue as our planet also continues to warm. For Up in the Air, I'm Mattis Uklo.